We're making good progress with the build and the printer is already starting to take shape now, so on we go with a relatively complex section of the build, the CoreXY assembly. This is a large section of the build, so we're going to get stuck straight in with the metal rod holders found in the CoreXY and hinges package. Note we need both front and rear parts as shown here. Starting with the larger left and right parts then, proceed to install two M3x10 screws into the side of the first rod holder. Do not tighten them completely for now, just a few turns is enough. We're just getting them in place for later. And repeat in the same two locations on the second holder, with another pair of M3x10 screws, again only so they catch for the moment. Moving to the rear holders, insert a single screw, again same principle, just so it catches without tightening just yet. Okay, so time to bring in the actual CoreXY plate now, placing it flat on your desk so that the bent edges are facing upwards, and so that the front protruding V section here is facing backwards. We need to get the two larger rod holders into place now, although note that both pieces are not identical, so we need to get placement right. Orientate both so that when looking in this view, both the larger holes are facing inwards, and both sets of screws are on the back side. Bearing that in mind, place the first holder on the left corner, notice how the corners match, and secure with two M3x6 screws, both going into the circular gaps and securing until snug. Repeat the same with the right side, again taking care to line up the holes and secure with a further two M3x6 screws. Okay, so we'll need to construct the central holders next. For these we'll need the two linear holders located in the metal parts package, the two XY carriages from the printed parts bag, two linear bearings complete in their casings from the CoreXY package, and four idler pulleys from the electronics and fasteners package. With all these to hand, we're ready to continue. Starting with the first 3D printed XY carriage then, orientated as shown here, taking note to keep the beveled edge to the front as a guide, and insert a pulley into the gap, before inserting a single M3x18 screw through the part and the pulley to keep it in place. Tighten the screw down so it's secure, while ensuring the pulley can still turn freely. Okay, so with that in place, rotate the part in order to insert another pulley and secure with another M3x18 screw. So now we have the carriage complete with two freely rotating pulleys in opposing corners. Repeat the same process with the second carriage, so secure the first pulley with an M3x18 screw, rotate, and secure a second pulley on the opposite side. With these prepared, we can go ahead and mount them to the linear holders. Bear in mind these are not identical. We have a left and a right side, so with the left side in hand and orientated as you see here, so the protrusion to the right facing backwards, place the first prepared carriage into position here, noting orientation, and secure using three M3x18 screws, two up top and one just below. With that done, turn the linear holder upside down and place a linear bearing alongside the carriage, securing it with four M3x8 black screws, one going into each corner, tightening until snug, leaving us with this. With the left side prepared, repeat the same process for the right side, so proceed to secure the carriage to the holder, again using three M3x18 screws, flip the assembly over, and attach a linear bearing, securing it with another four M3x8 screws. With both now prepared, we can go ahead and place these onto the CoreXY plate. Elevate the plate from the sides using some of your foam packaging so that the rod holders we installed previously are at the top, and proceed to place the first linear holder into position. Note this will only sit loosely for now, it's not actually attached to anything just yet. And repeat the same on the opposite side. Take note of orientation here, the bearing is on top, and the protruding section of each holder hangs down and is facing towards you. We'll secure these into position using two smooth rods. You'll find two sets of rods included in the package here. For the next steps, choose the shorter, thicker rods. These are 325mm in length with a 10mm diameter. Slide both rod holders into the rear rod ends we prepared previously, enough so that the rods line up flush with the holder, before feeding the first rod through the left linear holder and into the front left corner holder, where again we push the rod so it sits flush with the opposite end. Note that with it in place, the screw on the smaller holder should face the outside of the assembly. Repeat the same process on the opposite side with the right rod, so through the right linear holder and into the right front holder so it sits flush. And similarly, the screw on the smaller holder should also face the outer edge of the assembly. With both in place, line up the left rear rod holder with the threaded holes in the plate and secure it down onto the plate using two M3x6 screws until both are nice and snug. While we are here, we'll also firmly tighten the screw in the rod holder, which in turn grips the rod and secures it into position. Again, repeat on the opposite side with another two M3x6 screws to attach the holder to the plate, and tighten the side screw to firmly grip onto the rod. Finally, secure the grip on the other side of the rod by tightening the top screw in the holder. Do not touch the bottom screw at all. It's only the top screw we need to tighten here in order to grip the rod into position. Okay, so things are starting to take shape nicely now. So back we go to the printed parts package in order to retrieve the left and right motor mounts. These are not identical, so we'll need to take care when installing to ensure we get things the right way round. The left is the one with the single protrusion, while the right has two smaller protrusions. They're also labelled with a letter 2. Anyways, for the next steps, we'll also be using the printed multi-tool that we used earlier, as well as another 6 pulleys from the electronics and fasteners package. Okay, so we'll start by inserting the first pulley onto the multi-tool, then placing a spacer on top, which can get a little fidgety, followed by a second pulley, after which we insert the whole assembly into the right side motor mount, taking care to note orientation of the motor mount here. And once in place, align and insert a single M3x30 screw and then secure by screwing into place. You will feel some resistance here as you're screwing directly into plastic and creating threads as you go, so maintain a smooth and steady motion and do not over tighten, only until snug. Finally, remove the multi-tool and ensure both pulleys can turn freely, before inserting a third pulley into the corner just beside the first two, securing it with a single M3x18 screw. Same principle here as you're again screwing directly into plastic, so do not over tighten as you'll risk stripping the threads you've just created. Finally, insert a single M3 square nut into the top protrusion, just here. Okay, with that prepared, we need to repeat the process on the left motor mount too. So load up the multi-tool with a pulley, spacer, another pulley, and then drop down into the left motor mount, and secure with an M3x30 screw, just like the first, taking care not to over tighten. Before removing the tool completely, inserting the third pulley, and securing with a single M3x18 screw. And with that, both left and right motor mounts are complete. We'll move on to the belt tensioners next, 2 parts found in the printed parts bag. Again, note these are not identical and are clearly labelled for left or right. We'll also need 2 belt tensioner pulleys, also from the printed parts bag. Begin by inserting a single M3 square nut into each tensioner pulley, before reaching for the left tensioner, and inserting a pulley into the bottom. Notice the orientation of the part here. Fingers are pointing outwards and the side with the inserted nut to the top. To hold this in place, insert a single M3x30 screw through the top of the tensioner and towards the metal nut inserted in the pulley. Do not tighten down just yet. 3 or 4 turns are more than enough at the moment. After which we drop on a pulley and secure with an M3x18 screw, again driving into plastic so do not over tighten, and ensure the pulley rotates freely. Finally, insert a single M3x12 screw beside the pulley we just installed and secure with 5 turns of the screw. This screw must not protrude from the opposite side. It will be used later to adjust the door sensor. Okay, so with the left tensioner complete, it's a similar process for the right. So slide in the pulley mount with the nut facing up, secure with a M3x30 screw, remembering not to tighten, only 3 or 4 turns to catch the threads for now, before placing a pulley into position, and securing with an M3x18 screw going directly into plastic. So at this stage, we've prepared our belt tensioners as well as the motor mounts we prepared earlier. Starting with the motor mount then, we'll get these installed onto the main assembly first. Starting with the right mount, which is the simpler of the two. Place this next to the left corner on the CoreXY plate. This is a corner with a small protruding fasten connector sticking up. When placing the mount into position, this small rectangular protrusion will seat into the small rectangular cutout in the plate. So go ahead and slide the mount under the CoreXY plate, ensuring the rectangular protrusion fits into the cutout, before aligning the holes in both parts and securing with a single M3x6 screw in the designated hole right by the fasten connector. It's the same on the opposite side. Position the left mount beside the CoreXY plate as shown. Again, note the rectangular protrusion on the mount and the rectangular cutout on the CoreXY plate. Slide the mount under the plate, ensuring the rectangular protrusion fits into the cutout, before securing with an M3x6 screw in the designated hole until snug. Now we can go ahead and flip the assembly over and rotate so the motor mounts just installed are at the far end, and so that the folded edges face downwards. And starting with the left corner of the assembly, place the left tensioner into position, lining it up with the front and inner edges of the plate, and secure with 2 M3x30 screws on the inner side, and a single M3x18 screw on the opposite side, just enough until snug. That just leaves the one front right corner free, so drop on the final tensioner in this orientation, and secure into position with 3 M3x30 screws. So, in this orientation with the protruding V shape on the back side of the printer, your assembly should look exactly like this. Both motor mounts up top with bearing pointing backwards, and both tensioning mounts to the front two corners, with the one containing the door sensor tensioning screw on the left side. As long as your assembly looks exactly like this, you're good to proceed. And proceed we will with the linear rail beam found in the metal parts package, along with the linear rail from the electronics and chamber parts package. For now, it's important to ensure these green pins remain in place and do not fall off the rail at all. Instead, carefully wipe the preservative lubricant from the linear rail using a paper towel before placing it on the rail beam, making sure the holes on both line up, and with the carriage in the centre, proceed to insert and loosely tighten 2 M3x6 screws into the third holes from either end. Note we're not tightening these down fully, just enough for them to hold for now. Making sure the carriage stays in the centre of the rail, gently remove the first green pin from the end of the rail using needle nose pliers, and place it into the fourth hole along, next to the screw just inserted, before repeating on the opposite side, and leaving space to insert another 2 M3x6 screws into the fifth from the end holes beside the pins, taking care to again only slightly tighten for the moment. And then another 2 M3x6s into the very ends, again just slightly tightening, leaving us with this, so screws in the first, third and fifth holes. We'll need 6 M3x8 screws for the next step, although take care to ensure you have the correct screws with the rounded heads as shown here. With those to hand, bring in the CoreXY assembly, positioning it so that the motor mounts and the V shape on the frame are towards you, and move the two side linear holders to the centre of the Y axes. We can then place the linear rail assembly between the two holders, and use 3 of the M3x8 screws with rounded heads to loosely secure one side of the linear rail to its holder, before repeating on the opposite side with the remaining 3 screws. With all in place, proceed to revisit and tighten the screws until snug. At this point, we can safely remove the 2 safety pins from the rail, since the carriage can no longer fall off the end of the rail. Okay, so with that in place, back to the printed parts package in order to locate the rear bed stop module, as seen here. Begin by inserting two M3 square nuts into the bed stop from the first side, making sure they are inserted all the way, followed by a single M3 square nut from the opposite side, making sure they all line up. After which we can place this under the V protrusion on the CoreXY plate, and secure with another 3 of the M3x8 round head screws. Note the bottom 2 screws go into the metal square nuts we just inserted, while you will feel more resistance with the top screw as it's going straight into the plastic. Tighten until snug. With that done, it's time to prepare the Y and X axes motors, both found within the motors package, and both being clearly labelled depending upon the axes. We'll also need 2 motor pulleys from the electronics package, and the multi-tool we used earlier. Starting with the X-axis motor then, notice how the motor shaft has a flat side. Place the fork of the multi-tool onto the motor end of the shaft, in order to set the correct distance for the motor pulley, which can now slide on next, teeth side first, and with the grub screw facing so it's level with the flat side of the shaft. Proceed to tighten, after which we can remove the tool, rotate the pulley, and tighten the second grub screw. If done correctly, we should have a slight gap between the pulley and the base of the motor, as seen here. It's a similar process with the Y-axis motor, although instead of using the fork end of the multi-tool to set distance, we need to use the opposite hook end instead to set a larger distance, since the pulley slides on with the teeth facing the shaft tip this time. Tightening the first grub screw into the flat side of the shaft, before removing the tool, and rotating the pulley to tighten the second grub screw. So with the Y-axis we've set a larger distance and the teeth of the pulley facing outwards. The reason for this is that we have 2 belts to install covering both X and Y axes. By offsetting the motor pulleys we can offset the belts, so they sit beside each other. So talking of belts, we'll need both XY belts, as well as the Nextruder holder, all from the CoreXY and hinges parts package. And with these to hand, we can get the belts installed. Okay, so we're still facing the back end of the CoreXY assembly here, where we're going to focus on the left motor mount. Begin with the first belt, creating a loop so that the teeth are facing inwards, and push the loop in between the bottom 2 pulleys in the motor mount. Enough so that the loop circles around the entire void, since we now need the Y-axis motor in order to insert the pulley end into the top so that it sits between the belt loop, making sure that the motor is orientated so that the cable is facing back towards you, and pull the belt so it wraps more tightly around the motor pulley. We need to secure the motor into position now, so raise the CoreXY assembly up while at the same time grasping the motor in position so it doesn't move, also taking care to ensure the belt doesn't come loose, and proceed to secure from the bottom using 4 M3x35 screws. Tighten gently but firmly, before laying the assembly back down horizontally. Okay, so motor installed and belt still wrapped around the motor pulley. Next, guide the left side of the belt back around the left pulley so the teeth will be facing outwards here, and gently pull through towards the front left corner of the assembly. Now guide the belt around the pulley in the belt tensioner, again so teeth are facing outwards, back up towards the linear rail assembly where we guide it around the bottom pulley, and this end will now secure to the Nextruder holder, so holding it in this orientation with the larger hole to the left, push the end of the belt through the middle hole on the bottom row, and then back through the left hole, leaving 4 to 5 teeth sticking out. Notice how the teeth face inwards here. The belt is secured on this end now, so we can leave it free for the moment. And back to the other end of the belt then. Guide this end around the lower pulley in the opposite X motor mount, pushing it through to the front, and then route the belt around the lower right pulley in the linear rail holder, and back towards the Nextruder holder, where again we push it through the middle bottom hole alongside the other end of the belt, and back through the right hole, again so around 4 or 5 teeth come through. If you do find this step difficult, feel free to loosen the belt tensioning screw on the front of the assembly to provide more slack in the belt. And with that, the wire belt is now in place. So from the extruder mount, we go around the bottom pulley in the left linear rail holder, down and around the front left belt tensioner, up towards the left Y-axis motor mount where it loops in and around the motor, across to the opposite motor mount, down to the other end of the linear rail, and back across to the extruder mount. With that confirmed, we now need to complete the same process with the second belt for the X-axis. So create a loop with teeth facing inwards, and insert into the X-axis mount on the right side between the two pulleys, so just above the previous belt. Drop the motor down so that the motor pulley sits in between the belt and the motor is orientated so that the cable faces back towards you, before raising the assembly in order to secure the motor from the opposite side. Again using 4 M3x35 screws and tightening gently but firmly. Once secure, place the frame back down and guide the right side of the belt back around the right pulley, down towards the right front corner tensioner, guiding it around the pulley with teeth facing outwards, and back up to the linear rail where it goes around the front upper pulley, and across to the extruder mount where we now use the top set of holes, so in from the center and back in the right side by 4 or 5 teeth. So just the final end left now. Guide it across and around the top pulley in the Y-axis motor mount, around the final pulley by the linear rail, and across to the extruder mount again, now securing to the final remaining slot. Belts now installed. Double check your route for both belts, ensuring they do not cross and that they sit nicely in both motor pulleys. Belt tension will be set later. At this point, both motor wires should face back towards you. Starting with the left then, insert a single zip tie into the available hole in the lower protrusion, and guide the Y-axis motor cable down the channel, securing it into place by tightening the zip tie, before trimming the excess. Repeat the same with the opposite X-axis motor, securing the cable down its channel and tightening with a zip tie, before trimming the tail. With that done, back over on the Y-axis motor, insert a single M3 square nut into the opening on the side of the mount, enough to ensure it lines up with the corresponding hole, so that the Bowden guide, found in the printed parts package, can be placed on top and secured with a single M3x10 screw, only until snug. Notice the orientation of the part here, it should be protruding from the top. Okay, so with that done, we'll secure the extruder holder with the belt ends attached back to the linear rail carriage using 4 M3x10 screws. Loosely insert the screws and take care to ensure the belts are not obstructing any of the screws here. Then tighten. You do not want to be tearing or making holes in any of the belts, so proceed with caution and gently but firmly tighten all 4 screws until the mount is held firm. Okay, onto another LED strip next, found in the electronics and fasteners package, along with the CoreXY strut, located in the first metal parts package. Orientate the strut so that the flat side is facing upwards, as well as this rectangular cutout facing up towards you. When placing the LED strip into position, the cable needs to be on the same side as the cutout. Place the strip carefully in the middle of the strut, pushing down only on the free areas, so we're not touching the LEDs or other components on the strip at all. Flip the unit over so that the LED strip is now facing away from you and the cable is pointing out from the left side, and attach it to the front side of the CoreXY assembly between the 2 tensioners, securing it with 2 M3x4 screws until firmly in place. Before flipping the assembly over so that it rests on its motors, and with the LED strip still in front of you, albeit with the cable now protruding from the right side, install some zip ties in the cutout on the right side of the frame here, going in from one side and up out of the other, before partially tightening just the first few teeth, and repeating with the remaining 2 zip ties on this side, before flipping the assembly back over, as we now need to install the door sensor. This will attach to the left belt tensioner on the same side as the LED cable and the zip ties we just installed, using a single M2.5x10 screw going through the tensioner and into the mount. This acts as a pivot, so fully tighten, and then back the screw out a quarter turn, after which we can tighten the single M3x12 screw at the top of the tensioner mount just enough so that it touches the door sensor. We'll set correct placement if need be later. The door sensor cable can then be secured to the left tensioner mount with a single zip tie feeding through the available holes, after which we can cut off the tail. Okay, so now flip the assembly over again and place a box under the front bar to hold the entire assembly straight here in order to not damage the door sensor we just installed, before feeding both door sensor and LED strip cables through the 3 zip ties we loosely installed a moment ago. And tightening down the zip ties. Note you want the cables to be straight here, not leaving any slack since we don't want them to interfere with the linear rail as the bearing moves back and forth. So once verified, remove all tails. And with that, that's the CoreXY assembly pretty much complete, and we can go ahead and get this mounted to the main printer assembly. We'll need our final 2 smooth rods for the next step, so with those to hand, proceed to insert the first into the heatbed assembly corner bearing, and repeat on the opposite corner. Temporarily hang the cables from the fan assembly over the back panel for the moment, just to get them out of the way, and we can now bring the CoreXY assembly into play, in order to seat it on top of the main assembly. Note that the 2 rods we just inserted need to seat into the rod holders in the corners of the CoreXY panel. And the rear Z-axis threaded rod will protrude through the rear bed stop. As an extra check, feel free to ensure the CoreXY assembly is level with the bed. Once you are happy and the rods are in place, firmly tighten the first rod holder screw just under the tensioner mount, and then the second on the opposite side. From this point, take care when handling the printer, and do not lift the structure from the CoreXY assembly. Lift and move the printer only by lifting from the base. Okay, next move the linear carriage to the center as we need to tighten the rail screws, although in a specific pattern. So push the linear rail down slightly, and while doing so tighten the first screw on the left, then the screw on the very right, followed by the next screw on the left, and the next on the right, and finally the last inner screw on the left, and the final inner screw on the right. So with that done, around the back of the printer, push the FE connector through the oval hole, and from the side, push it straight onto the cable connector in the corner of the XY assembly, just here. And while we are here, we can push through the X motor cable through the same hole to the back, as well as the LED strip and door sensor cables. The fan and thermistor cables can also go through the rear panel hole just below. And finally, the Y-axis motor cable through the last respective hole located next to it. Okay, so back to the rear of the printer where we'll get all these cables installed now, although before doing so, move the fan cables to one side slightly and notice this small cutout on the back panel. Raise the CoreXY assembly from the opposite side a few millimeters and secure with a single M3x8 screw. Back to the cables now then, starting with the cooling fan cables, route them through the left hole in the electronics chassis, and plug them into the 4th and 5th slots on the X-Buddy extension board, labelled Fan 1 and Fan 2. It doesn't matter which go where, they both do the same job. Next, guide the thermistor cable through the same left hole, and connect it to the second slot, labelled Temp. Now guide the X motor cable through the right hole, and connect it to the left slot on the actual X-Buddy board, labelled X. Guide the door sensor cable next, the longer of the two, through the same right hole, and connect it to the lower slot on the left side of the board, just by the USB-C port. Guide the white LED strip cable also through the right hole, and connect it just beneath, so the second slot from the right on the extension board. And finally, guide the Y motor cable through the left hole in the chassis, in order to connect it to the second slot from the left on the board, labelled Y. And with that, the CoreXY assembly and this rather large and complex chapter is now complete. Your printer should be looking exactly like this now, so take a break before we move on to the next chapter, where we'll concentrate on the main Nextruder assembly.